Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Developer Express. Become a UI superhero with Dev Express controls and libraries. Deliver elegant .NET solutions that address customer needs today. By leveraging your existing knowledge, you can build next-generation touch-enabled solutions for tomorrow. You can download your free 30-day trial at dx.hanselminutes.com. That's dx.hanselminutes.com. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Adi Avivi from Hibernating Rhinos. He's a C# developer on the core team working on a product called RavenDB. Thanks for coming on the show.
Hi, Scott. Thank you.
Yeah, so RavenDB, what is that product?
RavenDB is a NoSQL document database, which means not only SQL database, and it refers to a different model than we are used to in tabular relational databases. For most real problems, a document database can provide better and faster solutions. In document databases, you store your data in RavenDB, in particular in JSON format. And then you can retrieve the information faster, and you are not restricted to schema changes. The database gives you more flexibility in changing the information and updating your data.
And this is a full database, though. It's an ACID database, right? It's a fully ACID database. So you have, it's atomic, it's consistent, it's got isolation, it's got durability. Mm-hmm. This, even though it's not something that maybe people are familiar with, a NoSQL database like this can still be fully transactional.
Yeah, RavenDB is transactional database, and the safety of the data is in its highest priority. When we store information, I'm talking about each transaction separately. We really keep the ACID properties in each of them. When you store information, you want it to be there up to the point that you shoot your computer. Unless you do that, your information should be there.
I hope I don't have to do that to my computer.
Yeah.
So how long has this been a project?
Well, this project started back in 2008 as a Windows-only server on .NET. And it got matured, and today with .NET Core, we are actually a cross-platform product. Well, it really, it wasn't easy to make it cross-platform because we had to rewrite many parts in this project. But today we can say that we are running, after 8 years, more than 8 years, not only on Windows Server, also on Linux and Mac.
Yeah. And not just Linux, but many, many different Linuxes, many distros.
Yeah.
There were a number of reasons that you wanted to move this over to .NET Core, weren't there?
Yeah, we had many driving reasons to do that. First, as we said, supporting various distros. And now that we can say that we are running, also on Mac and other devices and other architectures, many architectures. So RavenDB can run on any operating system supported by .NET Core. This is something great because the development efforts that you need to give for each architecture and each new distro is lower than you had to do previously.
was the hardest part moving it to .NET Core, or was there a bigger problem with the different CPU architectures? Like you also wanted to work to ARM.
Working in with the .NET Core community gives you a lot of benefits. You can get help from the community when you have problems, especially with working, on different architectures. Now, when we're talking about the ARM32, which specifically the Raspberry Pi is running on, yes, we had a lot of stability problems at first, and I mean, .NET Core was just released in its beta versions, but we got a lot of help from the community, and we followed the progress, and we we saw ourselves getting there, one step at a time, and finally we are there.
You've been running on Linux and .NET Core for a year, and you said that initially when you were working on beta versions of the framework, you had some stability issues?
At first, the CLR, the host of .NET, the host process of .NET, was not mature yet. So we suffered the stability issues. And we didn't give up. We tracked the announcement from the core CLR team, and when they declared the zero failing test state on the ARM32 architecture, for example, that was a signal to us to cross-compile the CLR and try RavenDB on the Pi. With few adjustments and the correct, Pi's system calls modifications, it worked. I remember, trying to do that in a hot summer day on the Pi, and the office air condition got broken in that very same day, and I ended up with 2 burned Raspberry Pis in the end. So yeah, we had the problems along the way. But we managed to fix everything, and today we ended up with full-scale transactional database on $35 Raspberry Pi, serving thousands of requests per second, and writing currently up to 2,500 documents per second transactionally on the Pi. That I would say, wouldn't shame an average production server.
Why did you want to put it on the Pi? Like, I think the most amazing part about this is there's so many amazing aspects to this from a story perspective, right? This is an 8-year-old or 9-year-old product. It was you could call it legacy code simply because it's older, but it ran only on Windows, but it was very well factored. It was very well written. You moved it to .NET Core. That allowed you to run it on multiple distros. But I think of RavenDB being more as a cloud kind of a database, or a big database I would use on a big company. Why was it important for you to run it on a Pi? Just because you could?
Well, we first want to say, yes, we can, run on any CPU, on any OS, on any bitness, but also supporting customers with low-end machines was on our mind. There are a lot of customers that running old machines, and to upgrade, the entire system could be costly, and running on 32 bits is something that can be in their interests. So this was a real big motive to make it work on a Pi or on any 32-bit machine.
And when you did this, though, because .NET Core didn't have an official ARM supported, much less an Raspberry Pi supported, how much did this mean that it was suddenly your job to get .NET Core running on ARM?
Well, I was developing in C++ on Linux for about 10 years, and then I got here, and everything was running on Windows. It was moving to another country for me, and I was brought here to make it work on Linux in general, and later on the Pi in particular. And I can tell you that at first, when you're looking on this tiny card, or on this tiny credit card sized computer, you say to yourself, it will never be something that can be, in production. It's more like a hobby, to make it work, to make RavenDB work on it. The huge scale of RavenDB, was a little bit, frightened at first. But I started to try the simple things at first, and as I said, when the .NET Core team, they did great job with the ARM32. When they said, okay, it can work, the Hello World program can work on it. I immediately, was pushing to see if we can do the more sophisticated stuff, like writing the transactional, writing transactions and keeping the ACID properties. Now, in an example, the fsync call, syncing the data to the disk, is something very important in transactional databases. And overcoming that, to get a better performance, we need to make a few optimizations. The optimization we did on the Raspberry Pi eventually gives us more performance on Linux in general, and also in Windows, by the way. I can give you an example of such an optimization. The transaction merging. Okay. When you commit a transaction, okay, you would expect the client to get a success response in a reasonable short time. When the database is in pressure of many requests, writing each transaction on the disk may take more time than writing all of them merged in a sequential way. However, it might increase the client response time latency. So what we did is thinking about this whole process like a bus station, where each person standing in the bus stop is a transaction, and arriving to the destination is like a successful ACID transaction. Mm-hmm. So if let's say if there aren't many people in the bus stop, it will be better for the bus to take only one person and let the other bus behind him take the next one. However, if there are a lot of people, let's fill the bus as much as we can. But one can ask, question like, the first person might wait for the bus to be filled more than he would wait as the first one, who got there. But the answer is that he will get to the destination faster, because his filled bus will not have to wait in the traffic jam of many buses before him, where, with a single person in each of them. So he can enjoy better performance by participating in this merger as a whole and gain a lower response latency eventually. So I hope this bus stop example gives us an idea about how we made an optimization on the Pi, and by that serving more requests, more writings per second, but keeping the transactional manner intact.
It's so interesting. It almost makes you wonder if this is like a best practice for software in general, that we should be testing on low-end machines to make sure we feel what that means. We really feel what low-end is like for our software. And then we used, if you make an optimization on a low-end machine, you'll have a great experience on a high-end machine.
Yes.
You just happen to go really low to a $35 computer.
Yeah. And when we say low-end machine, we are not talking only about processing power. We're also talking about memory. An example, it's using much. It gives you to use much less memory on the Pi, and by trying to operate with max performance on low memory hardware. Gives you later on Windows and on Linux better performance because of the way that you handle your memory. An example, at the points that matter in the aspect of performance, we allocated native memory and carefully reusing it and freeing it like you would do in C++. And in other places where you can use the garbage collector and save code, we are enjoying days of coding in C#. So if you look today on RavenDB project on .NET Core, you can see many parts that handle the memory in the code itself, and doesn't let the framework do that for you. So you can control the amount of memory that you use each second, and you benefit from it when you run on a big machine, because when you have to deal with memory garbage collecting all the time, you can lose performance on any machine.
How does RavenDB, does it put everything in memory, or does it have a balance? Like, how does it tune? Because not only, like you say, there's slow CPU, there's slow memory, there's also slow disk access. You're managing memory in some ways yourself, native memory. Mm-hmm. In some instances, you're letting the CLR manage the memory for you. But then you also have the disk access. I assume that your databases can be larger than the size of available memory, right? Much larger. So if you have can you have a 4 gigabyte database on a Pi, and then you'll do the right thing?
You can write more than 4 gigabytes database on 32 bits system. Mm-hmm. This is a very good example of a challenge we faced on the Pi. We used to map memory mapped files on 64 bits operating systems. Mm-hmm. And now when you deal with 32 bits, you need to use different techniques and to map only little windows in the memory and free it immediately, and manage your mapped windows and in general your memory. Mm-hmm. And we could actually what we did on the Pi in the end was importing the entire Stack Overflow site dataset into the Pi.
Oh my God!
Index it, and also querying the question and answers, and everything was done on the Pi on a big SD card. But the results were amazing, and it was done in a reasonable time. You would expect something like that, can take days, but it also it was really, really fast. Really, I really enjoyed this part. It was like the prize in the end of hard work.
Is this? Let me ask you this: do you have? How do you target the Pi? Do you have cross compilation? Do you have if defs, or are you actually using the same DLLs you use on Windows and on Mac?
We are using the same DLLs for our managed code. We have also a native code, and basically most of the APIs used for Linux works on the Pi. Of course, there are 32 bits APIs that we need, system calls that we need to use. But at start, we had to cross-compile the .NET and make some adjustments, like you said, with ifdefs to the Pi. Mm-hmm. But later on, we could ditch the ifdefs and the preprocessor defines. And I can say really simple and short modifications to the code. Most of it is now running as you would expect, cross-platform language to run on different devices and different business. This is something in the point of view of a developer and maintainer, a great thing, really great, really easy.
If you have continuous integration and continuous deployment, do you have a Raspberry Pi that is involved in that build process? So when someone puts their code into Raven, when they're one of the core developers like you, is that updating and being tested on the Raspberry Pi as well as all the other distributions?
Yeah, we have a testing environment, automatic testing environment, and we test Windows 64 and 32 bits and Linux 64 bits and the Raspberry Pi. We have in our server room, in a cooled server room.
In a cooled room.
It's important to keep the Pi cool. I already ended up with 2 burnt pies on a hot August day. Yes, we do test it. We can find many problems that you wouldn't find in faster machines. Mm-hmm. And I really recommend to do that in any project, trying to run your tests and running your real world scenarios on low-end machines.
I want to back up a little bit and understand the core CLR ARM process, because at the time that we're recording this at the end of March, and then in April, the show will come out. If you want to get core CLR running on a Raspberry Pi 2, this is something you have to kind of do manually. There's no official supported thing. Are you using public supported instructions, or is this because of your expertise doing Solaris work that's allowing you to do this?
At first, I had to do it myself. I had to use different skills to cross-compile and make it work with on different distros on Linux. But today we are talking at the end of March. The core CLR team managed to give a nightly build of .NET Core on the Raspberry Pi. So I think in the near future, people will be able just to download .NET Core on the Pi and run the programs. It's getting easier and easier in each day. You can feel, from a developer point of view, you can feel that with each day passing, the ease of use of .NET Core, almost is easy as running, on Windows previous .NET 4.5.
So it almost seems impossible, doesn't it, that you all pulled this off?
Yeah, I must say the day that we served the first request on the Pi, we raised the toast and we were very happy because it was involving a lot of challenges along the way. Mm-hmm. I think, but I can say that you don't have to dive into the bits and bytes of Linux as you had to do in previous years in order to have your application work in .NET Core. This is something
that actually brings up a good question, though. How do you debug this?
Yeah, in this part, well, I would want a better debugging experience on Linux as we have, in Windows. Today with the Visual Studio 2017, we can remotely debug the Linux machine through SSH. Also, profiling is not so easy as it on Windows. And this is a challenge for the community in the near future to achieve. On the Pi, there is no real way to debug and profile your application to date. On the ARM32 bits, currently you need to use different and more sophisticated techniques in order to solve programming problems. But I'm sure it will be changed in the near future because the people. The people in the different teams working all the time in very serious manner, and we're really looking forward to the debug options that will be open to us on Linux.
Are you able to debug this from Visual Studio remotely, you said?
Yeah, on Visual Studio 2017, the new Visual Studio gives us the possibility to debug Linux on .NET Core remotely. So you are sitting behind your Windows machine, debugging a Linux machine, .NET Core Linux machine, and you're feeling, at home. You're feeling, you feel the ease that you would when debugging a Windows application.
Wow! So it feels like any headless machine that just happens to be tiny and in your pocket.
Yeah, just like that. Yes.
So can you explain just a little bit briefly as we end here the relationship between the RavenDB open source project and the Hibernating Rhinos company? I can use RavenDB on my projects if I want to, and then I pay for support?
RavenDB is an open source project. Mm-hmm. Currently, we have on Windows we have an option to develop for free, and then you can get a license and support. I think when moving to the next version on .NET Core, this will be changed and will be more like you will be able to run a free version of RavenDB. Mm-hmm. This is something that I leave to our marketing department. I usually like to touch the bits and bytes under the hood.
Of course. Well, and that's actually a good opportunity for people to look at the bits and bytes. You can go to demo.ravendb.net. Mm-hmm. It's a really, really impressive online demo where you can go and see the C# code. You can put in the queries, hit run demo, and then see the output directly from a real server. So you can go to ravendb.net or demo.ravendb.net And again, this is not an advertisement. This is not something that they've paid for. It's just a really great open source project that's turned into a really great company. So I was excited to have Adi on the show to talk to us. Thanks so much for coming on today.
Thank you, Scott.
This has been another episode of Hansel Minutes. We'll see you again next week.